Saxon Algebra 1, Lesson 85. This is a classic lesson that most students enjoy. The first part is called stem and leaf plots. Now, first of all, let's just enjoy the randomness of that name, stem and leaf. And that's for what's going on in the math of this as well. Let's give these names. A stem has multiple leaves, right? There's one stem. But there's another stem, usually close by, that has its own leaves. Right? This is all going to, trust me, this is all going to make sense in a minute, and we'll have this lovely picture to contemplate. I'll go slow and spend a ton of time, which I'm not going to do, but I could. There, let's draw this with a little more care. Okay, so we have multiple stems and they each have leaves on them. We're going to create the mathematical version of this. And it happens in the world of statistics when we are trying to arrange our data in a meaningful way so that we can not get bogged down in a bunch of numbers but see patterns, okay? Example 85.1. Mark went to the driving range to test out the new golf club his brother Frank bought him for Christmas. Well, that was nice, Frank. Thank you. A new golf club. I wonder if he bought more than one, because just one golf club is kind of a sad gift, but a full set would be expensive. He hit 20 balls in a row, and the distance the balls traveled were, and then we have a whole bunch of numbers. Let me show you. Here's all the numbers. Okay, and it says create a stem and leaf plot of the distances listed, blah, blah, blah. I'm not going to read the instructions now. What we notice is that there are 20 scores here, 20 distances, and that they range, they range from, let's see, what's the lowest? I think it's 141, looks like the lowest, all the way up to the highest, the 180s. There's a 184, that looks like the highest one. Okay, so they range not from 0 to 100, but from 140 to the 180s. Let's put it like that, okay? So, a stem and leaf plot says, let's simplify this chart so that we can see these numbers and the without having to look at this whole ugly mess, because that, it's hard to get any good information out of that. So, what we do is we first decide on the stem part of this, okay? What are groups of numbers that make up this full assortment of scores that we can group together? And what we see is, okay, what if we put all the 140 scores together, the 150s together, the 160s together, and the 170s together. Oh, and the 180s, right? We can organize them by grouping together the numbers that are in the 140s, the 150s, 160s, 170s, 180s. What we do is truncate. Truncate is a fancy way of saying chop off the ones place numbers and just leave the hundreds and the tens, right? We've got hundreds and tens placed for each of these. When we do the leaves, those will be the digits in the ones place. So let's look through. You could organize this data in order from least to greatest, but I don't want to take the time to do that. In the 40s, I see there's a 148, a 147 and a 141. So we can write, we don't have to write them in order, we can just write 8, 7, 1. By putting these two pieces of information together, we can reconstruct, oh, this means we have 148, 147, and 141. These are the raw scores, right? That are represented in our stem and leaf plot. And then we do the same thing. We look through for the ones that start with 150. Okay, there's a 0. He only got one score in the 150s. And it was a 0, so we put that there. Now we look through for the 160s. 5, 2, 7, 8, 9. That's all of them. 5, 2, 7, 8, 9. And then so on and so forth for the 170s and the 180s. I'm just going to fill in the answers here without dragging the book back and forth. And there should be 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Uh-oh, I'm missing one. Oh, I don't think I counted that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, because there's a comma between them. So what this does is it takes our raw scores, puts them into a shorthand, I would say, that allows us to glance at these and go, okay, without doing any kind of calculation or counting, I can just see that his distances, he hit a lot of balls in the 160s and the 170s, right? And there were a few clinkers down here and a few really amazing ones, but most of his shots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of his 20 shots we can easily see were in the 150s and 160s. And if we wanted to, we could calculate a percentage of that. That's 60%, right? That would be over 100. 60% of his shots were in there. Okay, that might be helpful. So now we can see the value of this data. Here's another way we can use it. And now you can see how this picture, this is the stem, right? Like these are the 140s, these are the 150s, to draw a parallel to this. So for the first problem, what am I doing? This is 85, not 65. For the first problem, we actually built the stem and leaf plot. For this one, we're going to be given the stem and leaf plot, and I'm going to copy it here for you. So these numbers, we can see before we had 14, 15, 16, 17. In these, we're finding 800s, aren't we? And then here are the leaves, 8, 9, 6, 8. I want to point out to you that we don't necessarily have to put these in order from least to greatest. Sometimes I like to. I think it's easier just to read the data. But mathematically, by the rules, you don't have to. I also kind of like to write them in columns so I can see at a glance how many I have of each stem, right? So I can see, okay, this is pretty evenly spread, isn't it, across the 4 different stems? 4, 4, 5, and 4. Okay, this time we're being asked to take this data and find A, the range. Oh, these old guys, right? Range, median, mode, and mean. Okay, so we remember that these represent actual numbers. We want to find it for the range. That's the highest, or the greatest, minus the lowest. Okay, so we know that the lowest stem is going to be the lowest number in the 84 range. That would be 846. And the highest number will be the highest number here, 876. And we subtract those, and we get that the range equals 30. Okay, so we're not doing anything different in these calculations. We're just pulling the numbers off of our stem rather than having the actual raw scores in front of us. Now, John chooses to do that. He chooses to put them all in order, and then he works off of this list. I'm going to leave them in the stem and leaf plot, and let's see if we can do it that way without having to transfer them all into numbers. Okay, so we calculated the range. B, the median. The median is the one in the middle, and we have different procedures depending on whether there's an odd or an even number of data points, right? If it's odd, we take the one in the middle. If it's even, we take the average of the two in the middle. So we have to figure out what's in the middle. Okay, let's find out, or no, we have to find out how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so there's 17. So let's see, 8 plus 8 is 16. So there will be 8 lower, then 1 in the middle, and then 8 higher. So we want this one. So I'm going to start counting. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there are the first 8. So I want the lowest score in this stem. That would be 862. See how I did that? I counted off 8, and then I found the 9th element, which will be the very middle, and that would be the lowest in the 8-6 stem, and that would be the 2, and then there should be 8 more. 1, 2, 3, 4, 5, 6, 7, 8. Yes, so our median score is 862. C, the mode. That's the most popular. Okay, I'm going to draw a little divider here. Gracie's sleeping. Okay, the most popular, okay, it's going to have the same stem, so I'm looking for the number that has the most repeats in the leaf section. So here I see 2 8s, so 848. There are 2 of those. I see 853 shows up twice. I see 862 shows up twice. Oh boy, and then we have 876 and 873. Oops, I didn't need that comma there. That's just me being crazy. All right. I don't see any places where we have 3 of the same leaf, but I see 1, 2, 3, 4, 5 where we have 2 of the same. So all of these are the mode. So I'm going to list them here. 848, 853, 862, and I'm going to flip these just because I like them in order. So I'm just writing 873 first. So this is our mode. We have 5 modes in this data set. Weird, huh? That's correct. And then D, the mean is the average, and boy, that would be a lot of adding. We would add up all 17 numbers, and then we would divide by 17. Okay? You can use a calculator for this. That's just a ridiculous amount of work. I'm going to use John to tell me that the total is 14,620. Okay, if I convert all of these back into numbers and then add them all up, right? 848 plus 849 plus 846 plus 848 plus 854 plus 852 plus 853 plus 853. You see my point. You add all those up on the calculator, divide it by 17, and you will get the mean is 860. Sounds about even. Which makes sense because that's going to put it right here at the low end of this stem, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. That's exactly where we found the median. The middle data point was right there. The mode and the the median and the mean don't have to be the same, but if they are, if they are close together, then you just want to look and make sure that it seems like it makes sense, that the numbers are evenly spread. So this is how we can use a stem and leaf plot to calculate our statistical measures. And like I said before, you don't have to convert them back into the actual raw scores in order to use them. You would have to do it, this is the biggest place where you have to convert them from their stem and leaf format back into their regular format, because you can't add them like this. You have to put them back as to regular numbers. Okay, so that is lesson, or I'm sorry, that's not the end of the lesson. That's 85.2. 85.3. Example. Okay, now we're going to talk about something called histograms. A histogram is simply taking a stem and leaf, giving it a turn like this. We turn it in that direction, and then we turn it, and then we graph it. All right, so we're taking a table and we're changing it into a graph. And here is the only example. This is the last example, 85.3. We have that. The speeds of 40 cars as they pass the checkpoint are shown in the frequency distribution table below. Okay, so let's look at this. Check and make sure you can see it okay. I'm working down here at the bottom. I'm going to slide it up. No, because then that covers up the light. Oh, it's such a drama. There. Let's hope my phone doesn't fall. Okay, so this says speed of cars, miles per hour. Okay, 25, 30, 35, 40, 45, 50, 55. Frequency, number of cars. Okay, so they're clocking these cars as they drive down some street, and then they made a chart of them. How many cars had a speed? Oh, I wanted to say this. No, I don't want to say that. Never mind. This can be related to stem and leaf plots, but John is discussing it here as if it's a completely different subject. So don't worry about the connection between histograms and stem and leaf. Just consider this a different thing. It's fine. Later we'll see that they connect. And by later I mean Algebra 2. Okay, how many cars had a speed greater than or equal to 25 miles per hour and less than 30? Okay, so how many cars are in this chunk, right? Greater than 25 or greater, but less than 30. And we see the answer is right there. That would be 4 cars. Okay? I can see the answers on the next page. You guys can't. You'll have to trust me. B. What was the mode interval? Mode means most popular. And so we can simply look at the picture. Which one's the highest? Well, it's this one. It's between 35 and 40. Okay, so this interval, so that's what you would write is 35 to 40 interval, because it says, what was the mode interval? Interval means chunk, right? Section. What percent of the cars drove at a speed of less, oh, I'm so sorry, of less than 40 miles per hour? Okay, so we need under 40. How many cars did that? I need my piece of paper so I can write. How many cars were under 40, and then we do that as a percent. So we have 4 plus 10 plus 11. 4 we're at 25 to 30, 10 we're at 30 to 35, and 11 we're at 35 to 40. Let's make sure that's right. 4, see, I'm just reading across. I know you guys can tell that. 4, 10, and 11, and that's less than 40 miles an hour. And how many cars were there in all? John tells us 40. So this adds up to what, 25 out of 40. And we need to turn that into a percent. The easiest way to do it is just to divide 25 divided by 40. We need a decimal. 4 into 2 doesn't go. 4 into 25 goes 5 times. No, it goes 6 times. 6 times 4 is 24. And there's the 0. How many times does 40 go into 100? Twice. That's 80. Bring down another 0. 40 into 200, that's 4 into 20, that's 5 times. So 62.5% of the cars drove under 40 miles per hour. Is that right? Yes, that's the right answer. Okay? So we can use histograms just answering questions by reading them, or we can do some simple calculations with the data we have to get that. We can pull information off here and do little simple calculations with it. All right, that's the end of lesson 85. Goodbye.